in this video, we are just going to try and spend some time to explain the different laws that govern exponents. Like when you're working with exponents, there's a couple of laws that you can use to try and simplify exponential terms. Now, for example, we want to know whenever exponential terms are multiplied, how can you simplify that? When exponential terms are divided, how do you simplify that? And so on and so on, right? Now, we know for a fact that exponential terms like 5 to the power 3 here imply that this is 5 multiplied by itself 3 times. For example, if somebody says to me 2 cubed, that means 2 times 2 times 2, 3 times. It's just 2 multiplied by itself 3 times, right? So now let's try and explain how do you simplify an exponential term if you have to multiply certain terms that have got the same basis. We know this is the base, that's the exponent. This is the base, that is an exponent. So when you're multiplying same bases, how do you actually simplify that? So what does 5 cubed mean? 5 cubed means 5 times 5 times 5, 3 times. There's a multiplication sign in the middle, which I'm going to put there. And then there's 5 squared, which also means 5 is multiplied by itself 2 times. Now, when you look at this, how many 5s do we have now? It's 5 times 5 times 5 times 5 times 5, which is actually 5 of them in total. So this can just simply become 5 to the power 5. Now, you just compare this. Compare where 5 cubed times 5 squared comes from. How can I get this 3 and this 2 to give me that 5 you're looking at there? And you should agree with me that when you add 3 and 2, you will get the 5. So in essence, we can just say 5 cubed times 5 to the power of 2 can just be as good as 5 to the power of 5, which we get by adding those exponents. So in general, we can say when you're multiplying same bases with different exponents, what you need to do is just rewrite that and add your exponent. So this is going to be a to the power of p plus q. That's the first law of multiplying same bases. Now let's go to the second law, the one of dividing. 5 cubed divided by 5 squared. So 5 cubed means 5 times 5 times 5 divide by, here's my division, I'll use a division line. And then my 5 squared just means 5 multiplied by 5. Now when you look at this, if you try to simplify, 5 divided by 5 is a 1. 5 divided by another 5 is also going to be a 1. And I'm just left with this single 5 that is lying there. 1 times 1 times 5 is just equal to 5. Now, how can I use the fact that this was 5 cubed? This comes from 5 cubed divided by 5 squared. How can I use that result to achieve a 5 to the power of 1? If you think about it, the 3 and the 2, for them to give you a 1, you have to subtract them. So 3 minus 2 will give you that 1 we are getting there, which means when you're dividing same bases, you just have to subtract the exponent. It's going to be this exponent minus that exponent. That's how I'm going to get my 5 to the power of 1, which means in general, we can say a to the p divided by a to the q is just a to the power of that first exponent there minus that second exponent. Let's go to the third law of raising a power to a power, which means when you've got an exponential term raised to another exponent, what would that mean? Okay, cool. So we're going to take the example of 5 squared to the power of 3. So 5 squared to the power of 3 means it's this thing inside the bracket multiplied by itself 3 times. So that means we've got 5 squared, right? Multiplied by another 5 squared, and then multiplied by the last 5 squared. So it's the same thing multiplied by itself 3 times. Now 5 squared just means 5 times 5 times 5 squared means another 5 times 5 times 5 squared means another 5 times 5. So how many 5s are being multiplied here? This is repeated multiplication of 5s, which we can cut into 5 to the power of 1, 2, 3, 4, 5, 6. So this is going to be 5 to the power of 6. Once more, how can I get that exponent 2 and that exponent 3 to give me an exponent of 6? You'll agree with me, that just means 2 times 3. So we can then say, if you have 5 to the power 2 raised to the power of 3, you're just going to multiply the 2 and the 3, which is going to give you 5 to the power of 6. So in general, a to the power of p to the power of q can be written as a to the power of one exponent times the other exponent. Just multiply those exponents. Very powerful stuff. Now let's go to the next law of actually when you have different bases now. What happens if you don't have the same base? If you've got a different base, like in my example, I've got 5 times 4, which are not the same, all of them raised to the power of 3. How would you simplify something that looks like that? So we're not going to change the law. The law says this means whatever you have inside the bracket is multiplied by itself those many times. So that means this 5 times 4 cubed is just as good as saying 5 times 4 the first time times 5 times 4 the second time times 5 times 4 the third time. So we're doing the same thing 3 times. But look at the 5s. If I just multiply the 5s alone, I'm just going to have 5 times 5 times 5 because I've got 3 of them in total. And if you look at the 4s, I've got 1, 2, 3 of them in total. So that's 4 times 4 times 4. But this is repeated multiplication, which can be summed up to 5 to the power of 3. And again, this is repeated multiplication of the same base, which we can sum to 4 to the power of 3. That makes 5 times 4 cubed is just as good as saying this 3 can be given to the base 5 as a new exponent, and this 4 can be given to, and this 3 can be given to that base 4 as the new exponent. So this is just going to be 5 to the power of 3 multiplied by 4 to the power of 3, which we can then, in general, say if you have got different bases with the same exponent, this is a to the p multiplied by b to the power of p. The same story applies with division. The same story applies with division. If you give me let's use this one of 4 over 5. So 4 over 5 cubed is 4 over 5 times 4 over 5 times 4 over 5 3 times, which then you can notice that when we multiply numerators together. So it's 4 times 4 times 4 divided by 5 times 5 times 5 again on the denominator. And then in general, this is repeated multiplication. That's 4 cubed divided by 5 cubed. So if you compare this with the result that we're finding there at the end, it's as good as saying we're just raising 4 to that exponent and raising 5 to the same exponent. So it's 4 cubed divided by 5 to the power of 3. In general, a over b to the power of p is a to the power of p divided by b to the power of p. It's just as good as saying you're sharing the exponent. So these are the sharing laws. You share the exponent to this guy and that guy. Even here, you share the exponent there, and you also share the exponent there. Now, in closing, the red laws, these ones are very, very special. So what I'm going to do now is I'm going to try and show you what is any number raised to the power of 0 except 0 to the power of 0. What is any base raised to the power of 0? And what about when you've got negative exponent? How do you actually work with those kinds of things? So the first thing I'm going to do is I'm going to use an example so that you can see where this thing is coming from and where it is simply going. So let's imagine a situation where we had to work with the base 2. I want to know what is 2 to the power of minus 2 going to be. I want to know what is 2 to the minus 1. I want to know what is 2 to the power 0. I want to know 2 to the 1, 2 to the 2, 2 to the power of 3, and let's just stop at 2 to the power of 4. We can obviously go as many levels as we want. So let's start with something that you guys have an idea of. 2 to the power of 2 just means 1, 2. And you guys will agree with me that 2 to the power of 1 is just 2. But 2 squared is 2 times 2, which is 2 2's, which is going to give us an answer of 4. And then 2 to the power 3 is 2 times 2 times 2 3 times, which is going to give us an answer of 8. Similarly, 2 to the power 4 is 2 multiplied by itself 4 times, and that will leave you with an answer of 16. So let's pause here and check what is happening as you're moving from one number, moving on to the next one. Now, to move from 2 to the value of 4, you'll agree with me, this looks as good as saying we are multiplying by 2. To move from 4 to 8, again, you multiply 4 times 2, it gives you 8. And then to move from this one to the next one, you're multiplying by 2, and then 8 times 2 gives you a value of 16. And we can go on and on and on and on. Now, the reverse process of multiplication, what if you wanted to reverse this? We will then need to do the reverse process of multiplication, which is known as division. So let's divide and see. If I move from 16 back to 8, I'm going to have to divide by 2. 16 divided by 2 is going to give us 8. Now, to move from this level back, 8 divided by 2 once more will give us 4. We are reversing multiplication, so we are dividing. And then 4 divided by 2 will just give you a value of 2. Now, if I continue like this pattern has been going, if I divide by 2, then 2 divided by 2 is going to give us an answer of 1. Now, if I go further again, I divide this again by 2, you'll see that this is going to be 1 divided by 2, which is just 1 over 2. If I divide more by 2 again, it's just going to be 1 over 4, which can be written as 1 over 2 squared since 4 is as good as 2 to the power of 2. So then this actually answers the question we have about raising something to a negative exponent or raising something to a power of 0. So in general, we say when you raise any number to the power of 0, the answer will always be 1. So I'm going to put a value of 1 here. Even this 5 to the power 0 will just give you a value of 1. And then when you're raising something to a negative exponent, look at this. When it was 2 to the minus 1, the answer became 1 over 2 to the power 1. When it was 2 to the power negative 2, it became 1 over 2 to the power positive 2. So it just becomes 1 over the same exponent but with a different sign. So this is as good as 1 over 5 to the power of 2, which means in general, this is 1 over a to the power of p. The only one you can't work with is raising 0 to the power of 0, because when you try to do this division, you will be trying to divide by 0, and division by 0 is prohibited. We don't know the answer to that. It's undefined, so stay away from 0 to the power of 0. So any number to the power of 0 is 1 except 0 to the power of 0. And anything with a negative exponent is just 1 over that base with the same exponent that has a different sign.